So let's go ahead and start today by solving this problem from yesterday's notes, and we'll go from there. Okay. All right, so I'm going to solve this using substitution. I know that B is equivalent to 3A. Right? There's 3 times as many seats in section B as there are in section A. So I'm going to start by taking equation 1, and where I see a B, I'm going to replace it with 3A. So I'm going to have 75A plus 55B. Instead of writing B, I'm going to write 3A. And then plus 30L equals 870,000. And I'm going to do the same thing with equation 3. For equation 3, everywhere I see a B, I'm going to replace it with 3A. So I'll have A plus 3A. If you want, you can put it in parentheses. Plus L equals 23,000. And we're just going to simplify this. What is this? What is 75A plus 55 times 3A? Let's see. 55 times 3 is 165, right? So what would that be? 240. Okay, so this is 240A plus 30L equals 870,000. And then over here for equation 3, we would end up A plus 3A is 4A. Okay, 4A plus L equals 23,000. See how now we have two variable equations, right? Both equations have A and L. Pick a variable. Let's eliminate one of those variables. Let's pick maybe L. I don't know. Okay, I'm going to multiply this guy, this second equation, by negative 30, so that the L's will be eliminated. Okay, so equation 1, I'm going to keep the exact same. 240A plus 30L equals 870,000. And then I'm going to, multiply by negative 30 to equation 3. So what's 44 times negative 30? Thank you. Negative 120. A. L times negative 30 is the minus 30L. That's what we wanted. And then 23,000 times negative 30. I have negative 690,000. Is that what you guys get?
Yeah.
Thank you. Negative 690,000. We'll add those guys together. So 240 minus the 120 is going to be 120 of those A's left. Here those go away. And then 870,000 minus 690,000. I have 180,000. That's what you guys got? Is that right? Yeah. 180,000. And then divide both sides by 120. Right, we'll get what A is. What do I get for that? 1,500. Thank you. Okay, so that's how many seats there are in section A. There's 1,500 seats in the small section. Remember, there's 23,000 seats in the arena, so that's the section closest to the stage. Okay, so now where do I plug in 1,500 to get more information? Ron? Which one? Great, okay, that's good. So you can plug it in here. I could plug it in here, right? Or I like Ron's idea better. Let's go back up to this original equation, right? We had 3A equals B. Let's plug it in there. Okay, let's plug it into 3A equals B. 3A, 1,500 equals B. So what does B equal? What is 3 times 1,500? What is it? 4,500? Okay. Now I know A and B. Where can I plug in to get L? One of these original equations, right? I think 3 might be the easiest. Okay, A plus B plus L equals 23,000. A plus B plus L equals 23,000. We said that A was 1,500. Thank you. B we just said was 4,500. And then L is what I need to find. Okay, so what's L going to equal? What is 23,000 minus 1,500 and minus 4,500? 17,000? Okay. Yeah, that's what I got. Perfect. Okay, so my final answer then, A comma B comma L is 1,500, comma, 4,500, comma, 17,000. I'm going to make these exaggerated commas. Okay, so that means that there's 1,500 seats in section A, there's 4,500 seats in section B, and then there's 17,000 seats available in the lot.
If you were to graph this way easier, if you take off 2 zeros,
Well, this particular one would be kind of hard to graph because it's that third dimension. But you're right, if it was x comma y, you could take off some of the zeros and then just specify like in thousands or in hundreds, or you could take off some of the zeros and just label your axis. This is a good comment. Okay, any questions on that? Any questions on that? Okay. We're going to shift gears, now that you've seen another substitution example, over to this 1.4 day 3 notes. Okay. In 1.4 day 3, we are still going to be talking about 3 variable systems, except for now we're going to talk about the case where there's no solution and the case where there's many solutions. So last class we just focused on one single solution. So today we're going to talk about the other 2 possibilities. So remember, a solution is written as an order triple, x comma y comma z. And we talked about last class how there's these 3 situations that can happen. Last class we talked about how there's a possibility of only getting one solution. And here's what we're going to talk about today. The infinitely many solutions and no solution possibility. So infinitely many solutions, that happens when all 3 planes intersect in a line. Remember, there are an infinite amount of points on that line. The points of intersection are the solutions. So there's an infinite amount of solutions. There's also possibility for no solution. If all 3 planes don't intersect at the same point, then there's no solution. So we're going to run through a couple examples here. And you're going to see an example of no solution. That's going to be the first one. And then the second one's the infinite solution. Okay, and then from there we're going to kind of break off. And if you're interested in delving more into that, and you're interested in a possible extra credit opportunity, you can work through the next 2 examples with me. And if not, you can start on your homework or revisit the homework assignment that was due today and see if you can catch your mistakes. So in example 1, we have A, B, and C. I'm going to start this the same way. Let's go ahead and choose a variable we want to say goodbye to. Someone give me a variable we want to get rid of. Y. Okay, let's eliminate Y. Eliminate Y. So make the choice to eliminate Y. That looks good to me. Let's start with A and B. And we need negative 5Y for A. Right, so let's multiply A by negative 5. Right, get those Y's cancel. Negative 5 times A. And we'll keep B the same. So x times negative 5 is negative 5x. y times negative 5 is negative 5y, z times negative 5 is negative 5z, and that's going to equal a negative 10. Right? And b staying the exact same, 5x plus 5y plus 5z equals 3. Okay, all looks good? Okay, so we're going to add them together, and what happens? That goes. That goes. Oh my gosh, that goes. What's on the left side of the equal sign? 0, and on the right side of the equal sign is exactly what you said, negative 7. Is it true that 0 equals negative 7? No, that is not a true statement, right? This is not even a true statement. All my variables are gone, and I'm left with a statement that's not true. Okay, so that is an instance where you have no solution. If all of your variables drop out, and what's left is a statement that is not a true statement. No solution. That's it. Okay? If you get something that happens like that, you move on with your life. Okay? The second example is many solutions. And let's look at what happens for many solutions. A, B, and C. Okay. Let's start the same way. Pick a variable to eliminate.
Eliminate Z.
Z? I like Z because A and B, if I add those together, Z's will drop out. And if I pick like B and C and add those together, the Z's drop out? Okay, so let's do that. A and B, we don't even have to do anything to adjust them, right? X minus Y plus B equals negative 3. And B is X minus Y minus B equals negative 3. Is that right? Did I copy that down right?
Yeah.
Okay, thanks. All right, add them together. Here we'll get 2x minus 2y plus b minus c, goodbye, equals, that's going to be negative 6 when you add them together, right? Okay, so now let's do b and c. We'll have x minus y minus z equals negative 3. And here we get 5x minus 5y plus z equals negative 15. Add them together. We end up with 6x minus 6y. Those go away. Equals 15, 16, 17, 18, negative 18. Okay, so eliminate, eliminate. Now we look at option D and E. And I am going to eliminate again, right? I'm taking 3 to 2. Got to get down to one variable. So pick a variable you want to eliminate. X. Okay, sure. What would I have to do in order to get my x's to drop out? Yeah. Multiply.
Wait, hold on.
We got 6x. It'd be nice if this was a negative 6x. How am I going to make that happen? Multiply by negative 3, right? If I take d, right, and I take that 2x and multiply by negative 3, I would get a negative 6x, right? 6x and negative 6x. Those would cancel. Okay, so let's do d and e. So for d, I'm going to multiply that whole thing by negative 3. Okay, so this is going to be negative 6x plus 6y, right, equals positive 18. Is that right? Check my work for me as I go. 6x minus 6y equals negative 18 on the other side. For D, I lied, E. Okay. And there's our D and E. Right? Did I do that right?
Yeah.
Okay. So look what happened. Oh, not that. That's magic. That goes away. That goes away. What's left on my left side of the equal sign? 0. And what's 18 plus a negative 18? 0. See how I have no more variables? But does 0 equal 0? Yes. Okay, so this is a case where you have infinitely many solutions. Okay? That's your case where you have infinitely many solutions. Any questions about that? Okay. All right, so here's where we kind of break off into two paths, okay? If you're interested in extra credit, I'm going to continue this example, and it gets a little bit tricky on how you write your solution, so that's why this second part is extra credit on the test or quiz. If you're not interested in extra credit on test or quiz, you can either do one of two things. One is to make corrections to your 1.4 day 2 worksheet, okay? Or you can start on the 1.4 day 3 worksheet, okay? So those are your two assignments. So you can work on that independently now. I won't be offended if you start working on something else. Ron?
I need dumb questions, but what does it mean by infinitely many solutions?
That means there's a ton of solutions, like more than 1 million, like an infinite number. Like as many, like you can't even define how many
X,
solutions
Y,
there
and
are.
Z could all equal like 5, and it would work out.
Well, I'm going to tell, so that's what I'm doing for extra credit, is I'm going to write a general way to express the solution. So like an example might be like x, x plus 2, and x plus 3. If I pick a number for x, then that's going to affect my y and my z. So like this would be 4, and this would be 5, 2, 4, 5. Does that make sense? It's going to depend on what you pick as your x value. That will determine your other parts at that point. Okay, good question. Okay, so this is where we split. Tyler? Yes. Please do it in another color. I would super appreciate that. Yeah, I think even at the top of the 1.4 day 3 worksheet it says, like, do it in another color, or if you use pencil, if you use pen, something where I can differentiate what your original work was with the corrections. Does that make sense? Okay, so let's talk about how we would write our answer. So let me say that I want your answer, write answer in terms of x. Let's say that. I want your answer written in terms of x. Well, normally we have x, comma, y, comma, z, right? But I don't want y or z. I want it all written in terms of x. So here's how we do it. I already know what x is. X is just x. How am I going to rewrite y in terms of x? Well, let's go up here. Is there anywhere where we see a y? Yeah. Here's two equations with a y in it and an x in it. So I'm just going to pick one. Let's do this one, E. 6x minus 6y equals negative 18. 6x minus 6y equals negative 18. I want something to represent y. So I want to know what y equals in terms of x. So how am I going to get that? Well, I need to get y by itself. I'm going to subtract 6x on both sides. And then I'm going to divide everything by negative 6. That divided by negative 6 is just y. Negative 6x divided by negative 6 is x. Negative 18 divided by negative 6 would be a positive 3, right? So see how we just rewrote y in terms of x? Y is going to be x plus 3. Okay. Now I need to write z in terms of x. Where do you see an equation with z in it? Not there, not D or E. One of the original ones? Okay, so let's pick one. A. Someone read me A. Reread that to me.
X minus y plus z equals negative 3.
Okay, so now we know what x is, right? X is just x. Minus. Now we know what y is. What's y?
X plus 3.
X plus 3. And I need to know what z is, right? That's still the question mark. So I've got x minus x minus 3 plus z equals negative 3. And my whole goal is to get what z equals, right? What is x minus x? 0. Right? Anything minus itself would be 0. So I have negative 3 plus d equals negative 3. What is d? 0, right? If I add 3 to both sides, we're going to get that z equals 0. So that's what I'm going to put up here. Z equals, I don't want to cover up my work because I just did that work, 0. Okay, so that's how we get that. Now, what does this mean? What does it mean? Well, there's an infinite amount of solutions. So someone give me an x value.
4.
If x is 4, then what's my solution? 4, 4, 5, 6, 7, 7, 0. That's the solution of that system. Someone give me a different x value. 5, okay? If x is 5, then my y value is 8, and we have 0, right? See how you could pick any x value? You could do 100. X is 100. We would have 100, 103, 0. See how we have an infinite amount of solutions? Whatever y and z is going to depend on what x is. That's the whole idea. Okay. Let's try one more of these infinitely many. So I know that this second one here is going to give me infinitely many. So let's go ahead and do that. So we have A, B, and C. I'm going to go ahead and eliminate y. It looks easiest to me to eliminate. So let's see. I'm going to do A and B together. So I have x plus y plus z equals 8. And I have x minus y plus z equals 8. Right? We eliminate y. That's what I chose. Okay, so we're going to have 2x. The y's drop out. Plus 2z equals 16. And when I do B and C, x minus y plus z equals 8. 2x plus y plus 2z equals 16. What would I end up with? 3x plus 3z equals what? 24. Okay. So I'm going to call this my equation B and this my equation E. And then I make a choice of what variable I want to eliminate. Just going to do x again. Okay. Let's do x. So if I want to eliminate x, I'm going to take d and maybe multiply by negative 3. And maybe I take e and multiply by 2. Okay, I'm trying to get a negative 6x and a positive 6x. Right? Because then they would cancel. So that's going to be negative 6x minus 6b equals, what is that? What is 16 times negative 3? 48. Negative 48? Oh no. I think first. Okay, and then go ahead and multiply e by 2 for me. You should end up with 0 equals 0, right, if it's infinitely many. Oh no, it didn't copy all of them over. Okay. What we get? Negative 48. And then when I multiply that by 2, I would get 6x plus 60 equals positive 48. Right? So what do we see? 0 equals 0. Right? Not surprising because I told you it was an infinitely many solution example. Okay? Let's say this time I said right answer in terms of, let's do z. Okay, I want it in terms of z this time rather than x. That means that I'm going to have something for x, something for y, and I know that z is just z. That's what that means. So I need to know what x and y are in terms of z. So do I see anywhere where I have x and z together? Yeah. Okay, yeah, good. D, right? 2x plus 2z equals 16. Let's use that. 2x plus 2z equals 16. I need something for x. I need to know what x equals. What does x equal? Well, if I subtract 2z from both sides, I'll get 2x equals negative 2z plus 16. And then dividing everything by 2, right? Negative 2z divided by 2 is going to be negative z. And 16 divided by 2 is going to be 8. Right? I get that x is negative z plus 8. Right? And then I need to know what y is. How am I going to get y? Where do I see an equation with y in it?
B or A.
Sure.
Or
A, B, or C, right? Which one do you want to use? Let's just do x. X plus y plus z equals 8. That looks pretty easy. X plus y plus z equals 8. I know now that x is negative z plus 8. I don't know y, and I know that z is just z. So what happens? What happens to the z? Yep, negative z plus z, gone. So I have 8 plus y equals 8. So what's y equal? 0. Okay. So now I should be able to give you any value for z, and you can tell me a bunch of different points, right? Z is 2. Well, then that means that we're going to have 602, right? Z is 100, right? That means that we would have what? Z was 100. We would have negative 92, comma 0, comma 100, right? You can have an infinite amount of points, depending on what Z is. Okay? So that's the idea. Okay, so I'll have one of those on the test for extra credit. Write it in terms of whatever variable I choose. Okay, and then that'll be extra points. Cool. We still have some time left in here. We have about 6 minutes left or so. So if you have any questions, let me know. The